Hello guys, again I have question 11. It says study the opposite circuit and answer the following questions. I have R1 2 ohm, R2 5 ohm, and they say R3 equals to 2R2. It means it equals to 2 multiple 5. I will write 2 multiple 5, which equals 10 ohm. Okay? So, they say calculate the total resistance. Notice that R1, R2, R3 connected in parallel. So, I write the formula R equal 1 over R1 plus 1 over R2 plus 1 over R3 to the power negative 1. I will directly substitute here. It's going to be 1 over 2 plus 1 over 5 plus 1 over 10. Okay, to the power negative 1, remember. Okay, and the answer will be 1.25 ohm. This is the total resistance for the three of them. In B, they say calculate the current through the circuit. I need the total current that goes out of the battery, this current here. Okay, since they are asking about the total current, I'm going to use the total resistance that I got before. So I equal, it's the voltage supplied by the battery over the resistance of the circuit, the whole resistance, okay, which is going to be 15 over 1.25, and this will give me, use my calculator, it will give me 12 ampere. This is the current I. Okay, in part C, let me change the color here. Okay, in part C, they say find the power dissipated in R3. They need the power in the R3. Okay, as we agreed that R3 is connected in parallel with the battery, so it will have the same voltage. Here I will have 15 volt. Okay, the same goes for the R2. Of course, here it's 15 volt, and here also 15 volt. Okay, so the power, I use the power here, P equal, I have a formula, V squared over R. Okay, so it's going to be 15 squared, of course, which R? This is R3, right? Because they're asking about R3. R3 is 10. So 15 squared is going to be 225 over 10. So the answer is 22.5 watt. Okay, this is the power dissipated in resistor R3. Part D, they say calculate the electromotive force of the battery if the internal resistance is 0.5. Let me go up here. They say here inside the battery I have an internal resistance which is 0.5 ohm. Okay, so here I will draw. Okay, of course this 15 that was given, it is the voltage supplied for the external resistance. This is not E. Okay, this is the external voltage, V external, or what we call terminal voltage. Now I need the electromotive force, right? That's what they are saying, find electromotive force. Okay, so we write the formula. I have electromotive force equals to I have it I multiple terminal resistance or external resistance or the load, okay, plus the internal. Okay guys, the current is the one we found up here. It is 12. Okay, 12 multiple open bracket. We found the external, which is the total resistance. We found it 1.25, right? 1.25 plus the internal, it is given 0.5. Okay, use my calculator to do the the calculation here, I get E equals 21 volt. Okay, so again, I repeat, this 15, it's actually the voltage supplied for the terminal resistance. So it is V external or V terminal. Okay, and the electromotive force is going to be 21. It is the current multiple external plus internal. Now, next question, they say, what is meant by the voltage across the battery is 15? We know that the voltage in general, it is energy over charge, okay? W is the energy or the work, right? So we can say that 15 volt is actually the energy of 15 joule, okay, given to a charge of 1 coulomb, or we can say to 1 coulomb of charge, 1 coulomb of charge. Okay, because here I got the 15, so it's going to be 15 joule over 1 coulomb. By the way, you can say it is 30 joule over 2 coulomb, and define it as the energy of 30 joule given to a 2 coulomb of charge. Okay, it's up to you which one do you use, but the idea is that you will get the answer 15 volt. It doesn't matter if you put 15 over 1, 30 over 2, 45 over 3, it's up to you. Okay, I guess this is the last part. Yes, it is the last part. I hope it's clear. If you have any question, please leave it under the video. Okay guys, have a nice day. Bye bye.